Hello, everybody. We're going to begin by doing a wave across the crowd. All right. We may need to chase some people in from the snack table, but just because time is important, I'm going to go ahead and get going here. Thanks everybody for coming to this session. This is not the final session on BIM, but it's a very important one. It's one where we've put together some material on emerging trends with BIM it's called From Open Standards to Structures to International Initiatives. I wanted to begin because there's such there's a plethora of definitions of BIM. I want to just give you what Federal Highways, U.S. DOT Federal Highways has put together. So for us, it's not a particular technology. It's not a set of specific processes per se. It's essentially, I'll just read, an open standards-based collaborative work method for structuring, managing, and using data about transportation assets and networks through their life cycles. So I'll just kind of coin a phrase that Terry from Esri said yesterday, and that is, it's really a lot about how we use life cycle data management, how we integrate and utilize life cycle asset management, in our case, for highways. How will we, currently many of the systems that DOTs and transportation agencies use are disparate. The data is not connected, it's not organized, it's not integrated in a way that can be utilized well by the enterprise, for the agency's benefit. Just, think of data and how you could use data. I mean, the uses are unlimited, really, but certainly for the way we do, project delivery, the way we do decision making, the way in the future we'll do artificial intelligence and automation of processes. So really, BIM. I want to also clarify that BIM began as building information modeling, and the focus was initially on the model. It was on the design to construction model. The maturing of BIM that we're seeing around the world is better information management. So BIM is becoming more of a better information management because we know that the geospatial information and the associated information is powerful and maybe can be put together as a digital twin, if that term means anything to you. But really it's all about, kind of having a new view of data, life cycle data, collection of information that makes it much more powerful for an agency, for an enterprise to utilize that information. I think I also wanted to just do a quick, the connection to visualization. I mean, this is a visualization symposium. And so, and Kevin Gilson could probably give a lot more background on this, but, BIM by its nature is visual. I mean, it does include models, as in, 3D models and beyond. We had a presentation earlier on 4D models, and we have 5D models. So inherently, it enhances our ability to use visual tools to solve problems and to analyze things and look for clashes and to look for better optimized designs and so forth. So that is the connection of BIM to visualization. And if there's more than that, Kevin, please feel free to mention that when you come up. So I don't think I actually introduced myself. So I'm David Unkefer. I'm with the Federal Highway Administration. I am out of our Resource Center office and have been working with these digital technologies, deploying digital technologies for about probably 8 years. So I'm kind of a newbie, actually, compared to some of these folks. And so we are That's Federal Highways seeing the power of digital, and I'm just a part of that, especially as part of Everyday Counts, if you're familiar with that initiative. Our first presenter is going to be a presentation, BIM for Structures, the Pooled Fund, and the move to openBIM standards, because data standards are what are going to help us be somewhat more seamless. Maybe not completely seamless, Terry, but so we're going to begin with Jennifer Steen, who is the BIM director, I think, for local roads and highways for HDR, and then also Roger Grant, who's the vice president of building technology for NIBS, National Institute of Building Sciences. So come on up, guys.
And do we just use the clicker? This looks fun. I didn't have this in my last one. Oh, and I just realized I have a fun typo right there. So we're going to talk about the pooled fund, which is lots of fun. Okay, never mind. Oh, so today I'm going to talk about the Structures Pooled Fund overview and then pass it off to Roger, who's going to get into really the nitty-gritty and the fun part about this project. So, the overview. Has anybody ever heard of a pooled fund before? Okay, we've got some people. So for those who haven't, what this is doing is that these states, there's 24 states that have come together and they've pooled all of their money together to do a 5+ year project to be able to do a lot of research. And this is going to help impact all of these states and the US in general. So these are all the states that are participating, and they're trying to come together to be able to develop these standards that we're going to be talking about. So if they try to do this individually, it probably wouldn't work as well. And as we know, $100,000 isn't even like a quarter of some of these NCHRP research projects. So pulling all this money together to really make a change. And so they're focusing on the bridges and structures. So this is the BIM roadmap that they've come up with. And as you can see through this roadmap, there's been a lot of research and information that's been done well prior to getting the pooled fund together. And so as you can see, this is why it's so important to have these research projects. So if you're in the 80/80, working together with RNSs, this is why it's there and why it's so important. So you can see this roadmap online, and as you can tell, that we started the project itself in 2018, and then we've continued forward, and then we have some future work that we're doing too. So this roadmap also explains all the outcomes that they're looking for and the processes that overtook it. So next up, I'm going to give it to Roger, who's going to explain all of the fun stuff.
Yeah, all the fun stuff. Well, thank you. And so I did want to talk about the pooled fund and what it was set up to do and what it has accomplished, and a little bit about why it's important. There's a lot going on in digitization of the way we work. This has been happening for a while, but I think there's momentum gathering and needs are definitely there. So getting over to digital delivery, getting to transition to using a model of a project versus a set of drawings about a project as the basis for the work requirements is really important and starting to happen, and getting to digital materials to review and approve is also a big transition. And as David said, I'm with the National Institute of Building Sciences, so we work a lot with vertical buildings, and these kinds of transitions are happening there, but maybe it's taken a while for this progression to really kick in. And in fact, we're seeing in the infrastructure world things moving a lot more quickly. And this work like this fund is part of that work that Federal Highway has been investing in, as Jennifer showed on the roadmap in the years prior to the start of the pooled fund, has led up to that. And another key factor that you noticed from what Jennifer shared was, a nice thing in infrastructure, there are 50 owners of all the assets that we're trying to use these processes on, versus in the building world, there are thousands and thousands of owners, and the market power is not nearly as consolidated. So that is one of the advantages, I think, in the world of infrastructure and the development of common and shared and digitalized ways of working. And this is the vision of the project, of the pooled fund, and really, as I kind of along with what David said about building information management and modeling, it's really to develop an open way of exchanging information that's non-proprietary, that can be used, that has some value to the owner of the asset, not just to the people and other people involved in the process. Certainly, technology has a range of ways of delivering value, but what's really important is to be able to share and exchange information across the whole life cycle and have it be useful at for the asset owner. And in order to accomplish this, the idea was to develop a standard, an open standard that could be used and the information could be then shared. And so that's where IFC, Industry Foundation Class model, came into play. It's an international open standard for representing data about built environment. How many people are aware of what IFC is or have some knowledge of it? Okay, a few. So I'll just give a little background on IFC. IFC is one of three standards that work together to achieve interoperability, and that's it also is accompanied by a standard for describing a process, which is an information delivery manual approach to develop a standard process. IFC handles all the identification of the visual and the data aspects of a thing that's being built, and then the IFD works to create the terminology, a common set of terminology. And in fact, in the pooled fund, we're working with all three of these standards. They were developed initially by Building Smart, which was started in the US in the 1990s by Autodesk and other technology companies, but it has since progressed, moved to be used around the world. It's been also balloted and adopted as an ISO standard, which is really important, maybe more so outside of the US than here, but ISO standards are the foundational elements that then get used in regional and national standards. So in Europe, there's a common European standard framework that references ISO standards and adapts them, and then there's national standards, British Standards Institute, DIN in Germany. Here in the US, the comparable organization would be the American National Standards Institute, but the development of these kind of standards through our framework, this comparable framework here in the US, is not as advanced as it is around the world, and so we're working on that. That's a little bit of what we're aiming to try to do here in my organization and in others to advance these international standards and how they're applied and get the benefit from them. So maybe you want to know, what is IFC and why do we care about it? It's a non-proprietary open standard method of describing built environment and freely exchanging and visioning the information digitally. So it's for digital, it's about information, it includes geometry and data, information about the constructed elements. It tells you how to model it in a model authoring system so that it, as a solid or as the surface representation, that's all encoded in the standard, so it can be described and then the computer can render it. But importantly, it also includes semantics, it includes attributes, it includes relationships, there's a hierarchy, there's a schema that describes all of this that can be read by a computer, and that's the critical thing. It can create the visualization, but it also carries a lot of important information with it that can be used for multiple purposes. It is also started with buildings, but it now has been applied to all kinds of assets. In the latest version, alignment was added, and that really opened it up to the use in infrastructure. We've worked on it with bridges, but it's also being used with roadways, tunnels, and railways in particular. Around the world, there's a lot of activity in these other areas. For bridges, what we did was look at the interesting thing about bridges is they're a lot in common with buildings, and so We could use the kind of approaches we use to model buildings on a coordinate system and test those against the alignment system to figure out where to place things, and also what are the relationships that needed to be made between having a structure, allowing a structure to have parts, allowing those parts to have components, allowing those things to all be put together. And in buildings we talk about beams, in bridges you talk about girders, but they're the same construct. And so we went through in a research project for Federal Highway that my organization did to test how IFC would work for bridges, and made those kinds of initial relationships. And then the pooled fund picked that up and advanced it and continued to add to the implementation for bridges. It's important to know that IFC has been in place for quite some time, and it will continue to go forward. It is something that is not done. It is always evolving and being built on. New versions are coming out. We're on version 4.3 right now, and that will continue to progress, and that has progressed for quite some time. But what's really important about it is it has to be implemented some way, and that's where software companies need to come in to make it useful. And there are already over 200 software companies that integrate IFC around the world. About a quarter of those have been certified in their use of IFC. These are just some of those companies. What's important about that is, in order to have interoperability, in order to move data around, you need to have it be transitioned from one application to another one. Lots of software companies make ways of working together, but having a standard in the middle is a better scenario because you can leverage things a lot further. You can put multiple packages together through the standard, and you can put those packages, it can then integrate to other packages by just going through the standard instead of having to make all these multiple application-to-application mappings. So less work, lower threshold of interoperability, a larger ecosystem, theoretically more innovation, less cost for the owner. This is what an open system will do. This is what something like IFC allows. This is what's important about it. It's what's really important about it for government, because you don't want to request proprietary solutions to your problems. This gives you an open standard-based way to achieve interoperability, get your data, and hopefully have your data be reusable over and over again. So that's the advantage of an open standard, is owning the data, the information, which is critical to the asset owner, having it be transportable, movable. You can share it between multiple applications. Very importantly, you can map it to your internal systems, which is a big thing that many owners need to do. They've got all kinds of legacy systems. And then it's extensible, it keeps moving forward, it can be built on top of. So that's kind of IFC and why we got into it. And this project did some more research to look at what was going on in terms of the way the processes were documented, the way terminology was used, trying to work that through, and also take the IFC development work that was started by Federal Highway and move it forward, wrap it up, use the latest international work, and pull that together into the documentation of how to use IFC for bridges, and then very importantly, start to work with the outside community to get them to adopt and use this IFC model as the basis for how to exchange data about bridges. And the way that happens is that, and then finally there was some economic analysis. Everybody wants to know, is this really saving me money, or is it costing me money? Why should I do this? Of course, I would say just have faith and go forward, because it's better, but not everybody listens to me and others, but to some extent it is a bit of a journey. You're not going to, the value keeps accruing and building, there is important to keep looking at, why do we do this? What's it saving for us? How can we justify it? The team that worked on this was HDR was the lead contractor, and then there were some sub-consultants that they had that helped to do those tasks and activities. My role was, since we helped to lay the foundation for this pooled fund, I'm an advisor to the executive committee of the pooled fund, I guess. So, and we've worked together with this group of consultants and with industry. We've gone out and gotten software companies to participate. It's great to have a standard, but if nobody employs it, then it's not going to really it's not going to provide the value. So working with these software companies is really important, and that's going along. There's test models and test cases out there now that are being implemented, and so where we are as far as the roadmap goes is we have made a few important outcomes that the project set out to do. The information delivery manual that describes the process, you know, who creates data, who uses it, who exchanges it, who receives it, what are all these different exchanges and how do they interact. Writing that out is important so that it can then be encoded into software so that those processes can be supported. And that's the second thing the project did. It completed something called a model view definition, which is really a subset of the whole IFC standard that's tailored to just what you need to have to create that visual and data model of a bridge or of, you know, all the different range of bridges that you might have that you'd want to model. And it's set up to do that in the exchange going from the end of the design to construction. So it's basically the design model captured in a standard way, and using, you know, what we did was we looked at what's on a set of drawings. We had a couple of typical projects, and we just made sure that we could capture everything that was on those drawings using IFC and render it, and that's what proved the case. And then that has turned into this detailed representation of how it would be put into software, which is a model view definition. And then in addition to that, this idea of, it's kind of hard to read that from over here, but this other outcomes were the software certification. So what's it going to take? Put together materials that the software vendors can use to work with each other, and then help to get them informed on how to do that. And so the HDR team has been working on that, also interacting with Building Smart so that any advances in the standard itself would be captured. And we're now up to 2023, finishing up this work with the vendor community. Well, I shouldn't say finishing it up, but getting it to the point where Bentley can create a model based on IFC and output it, and another package could open it up and read it. We did that, actually helped to do that for AASHTOWare. AASHTOWare can write out an IFC file, and another software could read that in coming out of the Bridge BRD module of AASHTOWare. So the idea is to get this whole community of vendors working together so that they can write out data and read it in. It's really, you know, they're still going to do their creation and everything they do in their native formats, and you still want their native model, but also getting that IFC file model is really important. That's your archive, and that's also your ability to map to internal and to potentially reuse that later. So that's where we are. We're finishing up the 4th year of the pooled fund. We're just going into it. We're doing a 5th year. We're just finishing up the 4th year. We're going to do a 5th year, and then actually we're looking at another pooled fund for bridges to keep going for another 4-year period, because it's important that you have to keep the focus on this in order to get the implementation to take place. And so we think that's going to continue to happen from here, and that will extend this roadmap out further and hopefully create this ability to have models that can be shared, exchanged, used, provided, have the data in them that's needed. So this is just showing that it's really interesting, I think. AASHTO has voted as a community to, one, support and use IFC as a model, as a modeling standard, and then two, at the meeting in Pittsburgh this year, they adopted the IDM information delivery manual as an AASHTO, want to call it the right thing, guide specification, an AASHTO guide specification for the process of design to construction. Now, there's other processes, and the idea is to have this be an end-to-end solution. So that's one of the places where the pooled fund might go next, is to help to build this community of, having the requirements being established by engineers who are designing a bridge, have that information be able to be used effectively by the software, not have a bridge model that all of a sudden has a light post going down out of the bottom of it when it's supposed to go up out of the top of it. These are things that happen, but that's the kind of thing that testing does, and having the software be able to do that, and multiple packages ideally will get us there. And it will allow the bridge models to be visualized in a consistent and common way, and supported with, visualizations that become more and more accurate as the project progresses, so that design can be done at a preliminary stage, others can be engaged, and that's important. And then get that over to be able to be used by contractors and ultimately to the asset owner, so they can reuse that model over and over again. And the vision is that the states through AASHTO would be able to have different kinds of assets that also follow this. AASHTO and Federal Highway have just kicked off a pooled fund for roads that would take this same process and apply it to roads, and maybe it's really for infrastructure, I should say. So roadway would be a focus of it, but also these other infrastructures. And then we'd get to the point where we have this common standard, we can use it to go from design to construction to operation and end up with our digital as-built, or as we like to say now, our digital twin. So this is our strategy for BIM to twin for the, there I got a few good buzzwords in there, for the infrastructure world. And so that's what the pooled fund is doing. I think we can take a few questions now if we have them, or
Yeah. Any questions? Any answers? Go ahead. I think there's a mic there in case you want to use it.
Hi, good morning. So if my agency is looking to get into start using BIM, is that something, should we hold off until this, I guess, becomes the standard? Like, when do you expect this to be deployed, like mainstream?
Yeah, well, my answer to that would be don't hold off, because you have to have things, this is, it's not like a one and done thing. This is really a journey. You have to start with walk, crawl, run in order to really get implementation of this. So the standard will help to make it more effective, but there's a lot of other things needed to get your requirements in place, to get your contractors starting to use it and understand it, and then IFC will be added on and it'll be embedded in the software. So ultimately, when IFC is working, we as practitioners really won't even know it's there. It'll just be the way that data gets to where we want it to go.
Yeah, I just want to agree with Roger and just tell you that we have some implementation plans that have been built by other agencies, kind of capability maturity type thinking that kind of breaks the elephant of BIM down into more manageable implementation. If that makes sense, please feel free to contact us. So, other question? One more question? Yes, sir.
Wondering if there is a way to build like a software-free viewer just for all the BIM file, because I know that it has involved with the software developer. So how about you have your own just like a simple viewer rather to editing, then everyone can view the file rather than editing it.
There are several viewers out there that are available. There are free viewers, and then the different software companies like Bentley and Autodesk, they provide model viewers that can view the IFC file or their native model, and you can see it without having to be able to go in and, you know, manipulate anything in it. Is that what you were asking
Yes,
for? If
yes.
there's viewers that can do this? Yeah. And that's important because you need to be able to have people see that, interact with it, and work and understand it. Yeah, and that's good for also the digital review, you know, the review of deliverables. So, yeah.
Thank you.
Thank you.
So thanks, thank you, Roger. That's probably one of the better kind of laying out of the, you know, the complication of IFC and what we're trying to do. I mean, as a non-data scientist, you know, for me, it's basically just getting to more interoperable information. Right now, we have to do jump through too many hoops to share information. And so I'm hoping we get to like a whole new level of productivity as a result of interoperable information. So exchangeable, more exchangeable. So next up, we're going to have Making the Invisible Visible with BIM. So we have Dr. Jag Mallela, who is Senior Vice President of Research and Innovation at WSP. Also a good friend. Both he and Kevin, we've worked together on this for quite some time now, and Kevin Gilson, who is the Visualization Manager at WSP, so they're going to share with you a little bit about making the invisible visible.
All right, well, thank you, David. I need to set up here to switch to my computer, so just give me a minute. So thanks for the welcome, and while I'm doing that, I just want to acknowledge my colleague here, who was actually not prepared to be on the stage today, and I didn't know he was here either. So, but then the example I chose for the presentation was actually his. So I asked him, and David agreed, and he agreed most importantly, so I took off my jacket as a show of solidarity with him. So Kevin, thank you for this, and I think you can switch to this view, my computer.
Yeah, this is showing your computer.
It is? Okay, it's not on this, so.
So if you go back into the presentation, it seemed like it was on a different screen.
Oh, okay.
You just made the invisible visible.
There we go. I just did it. Awesome, I'm done. There we go. Well, thanks for making me say that. But actually, this title was an interesting one because I didn't pick this one. David helped me pick this one. And if I had a little bit more time, he'd put time pressure on me to pick this. But if I had a little bit more time, I wouldn't have been so ambitious in saying this. But technically, I think we will be proven right at the end of it because Kevin will show you things that we would not have seen otherwise if we didn't bring two disciplines together. One is BIM, and the other one is the art of visualization, which is the theme of this conference. And technically, we think visualization is seeing pretty pictures and animations, but really it's more than that. We all know that. And when you do that, you get such powerful insights that sometimes it boggles your mind and you can do things with it, which we are not doing today, but generally are not in the realm of our imagination. So first of all, just very simple understanding from my perspective on what visualization is. Visualization is a display of information, either through spatial views, 2D, 3D CAD, or abstract views, charts. And generally, when we talk about BIM and visualization coming together, we're talking about spatial views and the stream of science in visualization science. And we heard that from our kickoff, the keynote speaker today. There's a lot of theory that goes into taking scientific data and converting it into graphical representations to improve your understanding. So there's a stream that's called scientific visualization. That's associated specifically with spatial views. And then the second one is abstract views, which is taking data, numbers and things like that, and making it understandable. So that's called information visualization, which heat maps and tornado graphs and things like that. You'll see a lot of those in this conference. You probably already saw them. So that's taking abstract data and visualizing it. But we are sticking to spatial views, which is scientific visualization. And there are many, many applications of scientific visualization, and I'll show that in a bit. Now, how does this collide with BIM for infrastructure? So BIM for infrastructure is This is a definition in the Federal Highways National Strategic Roadmap, a collaborative work method for structuring, managing, and using data and information about transportation assets and networks throughout their life cycles. David mentioned better information management. That's basically what this is. It's not about a 3D model or a 2D graph or even a paper document. It's more about how the data is structured and how it is modeled so we can use it. So when it comes to BIM and visualization coming together, in certain phases, we specifically talk about 3D modeling, as the data model. 3D design model becomes our data model, and it helps us see things and get insights. But as you move on to the other phases of life cycle, the 3D could become a 2D, could be a GIS map, and could present information to us in ways that we have not seen before. So it's both 3D and 2D, but it is tied to spatial views. So I think that's where it comes together. The domains exercised in visualization, and you'll see this: computer animation, computer graphics, image processing, computer vision, computer-aided design, a topic of 3D modeling and BIM in general, and human-machine interaction and signal processing. Technically, all of these fall under scientific visualization techniques. Think about, I think, what has moved into the BIM space is the game engines people. They have actually created real-time visualizations, much richer viewing of an engineered model, so we can actually see operational impacts of what we design and put out there for the public. So think about where the industry is heading. It started with static imagery, then it went into animations, into graphics. That world, as you know, in seeing movies, it's just exploding, right? I mean, we're getting richer and richer content. On the BIM side, we talked about in the BIM track sessions, CAD information, GIS information. We talked about common data environments which bring all the information together, including dynamic data like sensors data, process intelligence, workflows, and workflow automation, information management processes, which BIM is actually technically an information management process. We also call it as BIM model, and that always gets me. It's a BIM model in terms of a noun, but it's not a delivery. It's a BIM data model always. And then data modeling techniques and how to link data. That's the discipline of BIM. So when these two come together, advanced visualization techniques and 3D BIM, you have outcomes that are more than the sum of parts, in the sense that we get insights into what we're building, which we would not otherwise have had. So you have to mix the scientific visualization discipline with the BIM engineered modeling and data modeling discipline to be able to get views that improve our comprehension and insight of what we're building, discover things that we could not have otherwise seen, and help in decision making. And that's the whole point of this. It's a very visually rich environment, and visuals always drive human interaction or human understanding more than words, or even graphs. So this is especially real-time visualization is getting more and more play in this. So how do visualization and BIM come together? There are many, many places where visualization, especially spatial views, and BIM can come together across the life cycle. You see, planning, for example, think about environmental analysis. You're trying to give alternatives to the public, say, this is my alternative for design. What better way to give them an immersive view of the alternative? Not just a picture, not just a rendering. I'm talking about an interactive, where they can actually go, click, see how things are. And that's what scientific visualization can do for you. It can make the invisible visible, because they can see it from multiple angles, multiple perspectives, different times of the day. Those are all things that visualization discipline brings together. Design, use cases related to design review and sustainability analysis. We're talking about carbon neutrality now, net zero. When you have goals in design, those are hard to put on paper and just document, like words on a page. It's better to show emissions in terms of analytics tied to bridge infrastructure that's being built through the Bridge Pool Fund IFC exchange, for example. So there's a lot of use case analysis in design that we all know, review of design, and other things that design has to do. In construction use cases, construction planning and execution, it's a bonanza for them. Essentially, that's where most of the visualization and BIM have come together, is essentially in work planning and work execution, especially during the construction phase, means and methods and things of that nature. Operations, several facility management operations are yet to be realized, but you can see most of BIM and visualization right now is in the 3D, 4D world, where the schedule is linked to a 3D model. But in the future, yesterday we talked about digital twinning. When you maintain that, not necessarily in a 3D spatial view, maybe it's in a 2D spatial view for linear infrastructure, start looking at how to manage facility and how to do that visually. You get insights just from looking at a map, or maybe you call up a 3D model from the map as an attribute, and start looking at that, or even do autonomous performance monitoring of that piece of infrastructure that you've built. So many use cases. So there is an amazing paper that I came across, 2020, done by Mallela et al. I hope I got the name right. That shows the application of visualization in BIM. It's a really good paper that summarized what all the applications are. And you can see the explosion is generally in construction planning and construction fabrication procurement. There is front-end application in design, and now there is emerging application in asset management and decommissioning and reprogramming of assets. But I think these two graphs, I think, are better graphs, from the same paper, which show how with time, how BIM and visualization have come together. In the design phase, you see the design reviews and the richness of the design visualizations are improving with time, but you see an explosion in the construction works planning, as we mentioned, with time, 1996 on the far left, and then on the right-hand side you have 2017. That's when the paper cut off its literature review. But then you see creeping up in there operational visualizations, And then by use case, within the life cycle phases, design reviews, and sustainability analysis, this is from the UK, but it's very similar to the United States. We don't have the net zero requirement yet. It is coming, right? Now it's coming, it's on us. So we'll see the same pickup, I think. So when we get into sustainability analysis and design reviews, there is still significant interest. But what really is taking off here is the work execution, which is in the 4D modeling and facility management. So again, by use case also you see an interesting trend in terms of where BIM and visualization are coming together. The context of visualization has also changed. Initially visualization was used for client approvals and public approvals. Now we're getting, as we saw from those graphs, getting in, beyond that to design coordination review, to clash detection and scheduling, to facility management and operations. So there is a demand to bring these two disciplines together. And the part of making invisible visible is, think of when you have the power of visualization, have you ever seen a black hole? Image of a black hole? It's basically scientific data brought together in a graphical format. It's essentially, it is a technique. It's similarly, I think there is, and I have pictures later, I think the neutron collision, is another, again, it's things that we cannot see, can be seen in visualization. I think we may not go to a black hole level or even a neutron collision level, but neutron star collision level, but I think Kevin is going to come up and talk about a specific project in which a lot of these things have come, a pretty major project, and hopefully he'll illustrate all of these as we walk. No pressure, Kevin.
Yeah, thanks, Jay. So we thought this was a good example of that synergy between visualization and BIM. This is a project we're doing for Connecticut DOT. WSP is the program manager. We're working for the client. HNTB was designing the bridge. And then there's a construction JV that's doing the planning, the scheduling, the planning for construction. It's been going on for some time, and as with most of these large projects, the original goal for visualization was to work with the designers to develop visualizations that would show people what the project was going to look like. What were the design alternatives? What were they going to look like in context? The designers developed most of the models of the proposed designs, and then we as program managers worked with them to incorporate these into a common environment to show in context what the proposal would look like. It's a bridge replacement in a historic town in the Northeast Corridor, the busiest rail corridor in the country. It was owned by Condot managed the site, and it was very much like a roadway with a bridge because they had to, as part of the process, we had to maintain traffic on the tracks during construction. So very complex construction staging. Early on, we knew that we were going to be seeing this model through construction, so we tried to develop a process and identify some tools that we would use throughout the project to support different goals for the outputs of the model. Very similar to the graphic that Jag showed, where there were certain goals during design, certain goals during construction, and ultimately the model will hopefully evolve into something to be used for operations and maintenance. We tried to create a collaborative environment for the model so that everybody was benefiting from using this common model. We established a common data environment, coordinates, naming conventions, somewhat of a BIM execution plan, but we didn't call it that when we developed it. It was really just a way to share data across the life cycle of the project and use it for different goals depending on the life cycle stage of the project. So early on, the existing model, the context model for the project, was developed around existing conditions that were captured using LiDAR, both LiDAR along the tracks as well as captures for each of the older structures that were being replaced. And that was turned into an existing conditions model. We wanted it to be very accurate, both for clash detection of the proposed designs, but also just to really represent what the project was going to look like as accurately as possible. Early on, we were using Navisworks, and we were using rendering tools like 3D Studio Max to produce visualizations. But as the project got closer to construction and the contractor was developing means and methods for building some of these complex structures, you know, the team started wondering, and the stakeholders started asking, what was this project going to look like during construction? We don't want to know just what it's going to look like when it's done, but what will it look like during these 5 years of disruption to the town? And so as part of that, we developed a real-time model that was intended to be used both for stakeholder communication as well as internal communication for the team, something we could all look at and collaborate around. Some of you may have seen this outside. Originally, it was just a before and after model showing what the project was going to look like once it was complete. But as part of the development during construction, we incorporated the construction stages of the project into the real-time model so that you could walk through and see in real time what the project would look like during those stages. So here I'm scrubbing a little button, and you're seeing the stage number on the left. This is what the site will look like during these various stages of construction. And then we also developed some animations using information from the contractor, which showed what some of these complex activities were going to look like. So here we're seeing demolition of this high tower on the left, and this is a residential building on the left. So, you know, very, very significant impacts to the residents of the town. So this was used both for a public outreach effort as well as, you know, showing what the contractor was planning to the client. So when the project reached 90% design, the schedule was becoming a critical part of the project process and how was it going to work. HNTB and the CMJV were working together on how we were going to build this thing, and they were developing a lot of concepts for those construction activities. But the schedule was becoming the critical part of it. So we made a decision working with the contractor to start developing a 4D model in Synchro, mainly because the scheduler for the contractor had used it before to help refine and develop schedules. And so they made a commitment to use Synchro for the 4D model. Again, it's the benefits of a 4D model. You've seen other presentations about that. You know, it refines the schedule, it finds temporal conflicts, it identifies where significant activities are occurring around each other so that you can plan around that. It was really about the construction activities and how those could be improved and risks could be identified. This was our process at that point in time. Once we started working with a schedule, we developed a little more complex workflow, mainly because we were working in an environment that was really more conducive to Navisworks. So we were bringing our model through Navisworks, bringing in a schedule, linking them in Synchro, but we were also carrying this model forward as a real-time model in UE4 concurrently with the 4D model. So this is an example of This is one of the 4D model renderings that we created for the project. If you're not familiar with what the term of a 4D model is, we have a schedule, we have a 3D elements that are broken up by the activities, and then they're linked together in a tool like Navisworks or Synchro, and they allow you to create these simulations that show construction over time. And we put some equipment in there where there were activities identified for that in the schedule. But you can see that it's a pretty complex series of activities happening in a very confined space. So a 4D model was really a useful tool to communicate those risks and the complexity of the activity. So during this process, anytime an issue was identified, we met as a team, we'd look at the model, we'd review it, we'd identify schedule issues, design issues, construction issues, and those were categorized in a spreadsheet and then pushed out to each of the significant parties to resolve those issues. And just out of interest, we did do sort of a quick run on what was found between 90% and 100%. And it was interesting that most of them were schedule related or just model issues. But there were some design issues that were found as well. So with that, I'll hand it back to Jack. Thank you.
Thanks, Kevin. So you may see this graph and say, what's the big deal about visualization? This seems like a standardized BIM outcome, right? You reduce clashes in a 4D, and I specifically asked Kevin, what was the visualization contribution to this, especially the scientific visualization conflict? And he told me that there were certain scheduling conflicts that would not have been picked up were it not for these renderings here. You want to carry?
Yeah, I think that when you run a 4D model, you inevitably find temporal conflicts, things that are happening concurrently to each other that are very hard to read in a Gantt chart when those activities might be spread way apart. So I think that it really helped them refine their schedule, even change the schedule where they felt there were issues that were happening at the same time that should be pushed apart. So, yeah.
Right. And then the second question I asked is, who found value in this? Is it the designer, the contractor, or the owner? And I think found value, in this. And it was clearly, obviously, this evolved in terms of, the initial scope was public communications, then into design review, into now construction scheduling. Clearly, the value was seen by the owner because they were getting better insights with a realistic model that is interactive, that they could see in different settings and contexts, and they were able to monitor the project much more efficiently in virtual design and construction phases. And clearly, that is intangible. Visualization brings certain understandings, especially on the means and methods, and especially in the works that the contracted parties will do, which otherwise would fall aside. So I just want to emphasize the points about, this is not about pretty pictures alone. It is about actual adding value to the context of the project. So in summary, I think the project demonstration in general, what visualization does is it allows the use of spatial views in scientific visualization to compress pretty large volumes of data. In those little renderings you see, there is a lot of science behind how to render an image. It is not, that's the entire science of visualization is kind of compressed in tooling that we have available today. It compresses large volumes of data into a limited number of pictures. It reveals correlation in different quantities in space and time. You saw the construction sequencing and the means and methods of the crane lifts and things of that sort, which is not just photorealistic, it is actually engineering grade accuracy. You can actually do that and actually say, I built this project virtually, now I can go build it really with my real equipment, and allows viewing of data selectively and interactively in real time. And those are the pictures of the neutron star collision and the black hole. These would not have happened without visualization techniques, and similar techniques, to unearth things that we cannot see, are being done, in our world in a limited basis. I'd say there is a lot of scope for visualization in BIM. It's a largely unexplored area. To be honest, it is not completely done. There are traditional information visualization techniques like data, abstract views that can be superimposed with visuals. We're still not there yet. We're not using the great work that's done in information visualization and combining that with spatial views. Data mining is a field, discovery, automatic, machine learning algorithms, especially for temporal conflicts. you don't have to see to react manually. You can actually do this with machines, and that's still to be done, especially in the temporality. I think in IDM, we talked about a BIM for bridges, IDM for pre-construction. IDM should be developed specifically for visualization, I believe, because it has a lots of value. And I'm just showing a picture down below of another project that WSP is working on in the Interstate Bridge Replacement Program, where a very large effort is being focused on visualization and use of data, both during the project development phase, but also post-construction to make it a smart bridge during operation. So that's the facilities management aspect we'll go to. So anyway, that's the end of our presentation. I know, are we on time?
Yes.
Over time. Thank you.
We're in good shape. So, how about a question or two for Jag and Kevin? Yes, sir.
File size. That's
What
you,
are
Kevin.
the file types?
Yeah, no, I know, I'm just curious. I think the 4D model is probably about 2 gigs. The real-time model is more, that's 6 or 7 because of all the fidelity that's added into it. But they're becoming distributable, even at that size, I think, but. Yeah,
Does it
they're
work
big.
better on the cloud, Kevin?
You want to use the mic?
Well, we're finding now, with the real-time model, we're actually investigating some streaming applications where the real-time models actually run on the cloud, and you're just using a client to view it. So that'll make that issue of size less important. But in terms of the 4D model and sharing it amongst the team, we had a common server project-wise, where we could share it. So it was nobody had issues with the size of it, so.
I think the real-time viewing in cloud is going to be the norm, if it's not already the norm, right? I mean,
Yeah.
it's the light,
Yeah.
thin client, yeah.
Yeah. So, John?
Great presentation. Thank you very much. It's very interesting to see a 4D model in action. So my question is, to make the 4D model in real time, what additional data or information you need to collect during construction to incorporate and influence your model?
Well, the designer is developing their project in 3D. The contractor is developing a series of steps for constructing that, and then they're developing a schedule for those steps. So those were the 3 main components that we had for the model. We did have to build some context and some temporary structures. And then it was all brought together into a single product.
Yeah.
So, are you done?
Yeah.
Yeah, I think one thing that we missed, I think mentioning, Kevin, is what you had to do, put in place ahead of time at the very beginning to be able to do this. Maybe that's part of the question is,
No, I think he's asking
Yes,
as you
well,
Right.
update it.
It's
update it.
understandable
understand.
from a survey to design, totally done in 3D. Then you tie that into schedule, so you have a 4D, model. But for the real time, the contractor would place where the cranes at, where the stockpile of their material, all of that. That is a sort of unpredictable, during the design stage. So the question, I guess, particularly, have you collected
Right,
data?
all
to
those
incorporate?
components were provided to the client, and we as program managers were reviewing all those components. So the contractor provided means and methods drawings for every complex part of the construction, and then the designer provided models for those elements, or CAD drawings, which we had to turn into 3D in some cases, but, and then a schedule.
there were 22 stages, I think, steps of the construction that were already pre-modeled or provided, that were modeled into the engineered software.
But it never gets built the way you draw it. Is that what you're asking, a part of
Well,
what you're
that's
asking?
another
It's,
end
there's
of the
real
question.
time. So I don't know if Phil's gonna talk about this, but New York State used the model for construction management, and maybe you guys did this too, I don't know, but they literally updated the model weekly, Phil? I don't know. They were, so essentially they took the updated schedule that had the matching activities and model elements, and they just updated the schedule. So people could see, and I believe you could see the changes in how things didn't get built on time or whatever. Is that what you guys did too? Yeah, okay. So same idea as you just because it's built to ingest the, the schedule, you just give it the the updated schedule. Did we answer your question?
Yes, certainly.
Okay.
Well, thank
All
you.
right. So thank you, guys. That was excellent. And, I'm putting on my glasses so I can try to make the invisible visible. So bringing it home are two other colleagues and friends that I've worked with for some time now, especially with TRB and the BIM committee and other places. But we're going to have Chuck Hickson, who's the business director for Digital Construction Works, and Phil Bell, who is used to be with New York State DOT, now with, has his own company, Progression Dynamics. And so tell us about applying BIM and digital twin practices on a heavy civil transportation project owner's perspective.
Thank you, sir. Hey, good morning. How are we doing out there? Final day, so close to lunch, but yet so far. So hopefully Phil and I will make you forget a little bit about lunch today. So today we're going to talk more about BIM in use and some of the challenges we're facing and trends as well. So I'm going to skip rapidly over us and get right to the meat of the matter on some of the things we've seen. I've been having conversations with agencies throughout the United States in the last year, and these are some of the notable things that have come out of those conversations. And many of the hurdles that are needed to cross really don't have to do with technology. They have to do more with the internal processes of these agencies and how they function. I like to show this slide because when we're talking about these technologies, it's definitely more than one piece of software. It's more than one piece of data. It's more than one workflow. We're talking about a collective of many things, and these are disruptors to the workflows that are in place today. And when you disrupt, you tend to have resistance as well. I think often when we look at some of these slides, we become overwhelmed. And it's almost like, asking the Wright brothers to build a rocket before they build a plane. You got to learn to do things and build upon them. And sometimes a holistic approach is a real challenge. And the same kind of theme is, we're dealing with new workflows. I've been with the visualization committee for over 20 years, and back in the day, we were excited when we can tether a couple 486s together to render out one frame in a couple of days. Those were the exciting days. And we've migrated over time, as Jag alluded to. We're not in that 3D space anymore. We're actually beyond. There's many Ds we're all dealing with these days. And where do we fit into those Ds? Certainly is a challenge as well. As I mentioned earlier, there's a lot of tools that we have to use today to make BIM, digital twin, et cetera, work. And one of my observations here during these last 2 days is we're considered the thought leaders in our field. And we have, I don't know how many definitions of a digital twin or BIM or 4D or 5D. I heard, and rightfully so in several earlier presentations, that we are not providing an effective message to the leadership to implement these workflows. And I think we need to look inward within ourselves to realize that if we can't all agree on one term for a digital twin, then we got some work ahead of us to do. So again, these tools all have to integrate these days. So as Roger alluded earlier with IFC, we're thinking beyond one use of that tool. For example, you might use a digital terrain model for automated machine guidance and grading. You got to think beyond that now. What else are we doing with that data? How are we integrating that data to other information? For example, are we not only going to use that for cut and fill and mass haul, are we going to now integrate it with the schedule in a 4D mode so we know where we stand with cut and fill? Are we ahead? Are we behind schedule? And Phil, in a few minutes, has some practical examples of that 4D workflow. But many tools you're dealing with now, which again is a hindrance to things. I think I talked to a lot of agencies and they're plumb just overwhelmed. I won't name some of the DOTs, but I hear, Chuck, we're just trying to get ORD to work. I can't even think of BIM. So things to realize that, you know, there's a lot of technology being thrown at everyone out there. A challenge to the TRB and every other organization is the speed of information only accelerates every year. And if you look at this slide, you can see we're talking about massive amounts of data and massive amounts of change happening rapidly. And I too would like effective case studies or synthesis studies to help me make better decisions, but the process to create them takes years. And by the time they're released, they're incredibly outdated. I think inward with ourselves and a challenge to the TRB is we got to somehow keep up with this pace. I don't have the answer to that, but that's, again, another challenge and trend that, you know, you're seeing out there. So lessons learned, and the first bullet is the most important, and I alluded to it earlier, and the recipe for any successful program implementing a digital twin or digital delivery or BIM for infrastructure starts at the top. And a lot of those reasons have nothing to do with technology. I've spoken to many agencies and I've discovered that their design, construction, and asset management groups really are siloed. They don't talk to each other and they're quite independent of each other. So getting construction to change their ways to do something that you want done in design is not an easy ask. Things to realize. Again, we have technology challenges, but we also have bureaucracy and workflow challenges as well. But with top-down leadership, a lot of those walls are broken down. And again, I think we got to go back and have a better message that we're sending out to the leaders of our agencies. A big one, and Phil will really stress this, is engaging all the departments. When you're going to implement we'll call it a digital delivery program, all the stakeholders are vital. Observations I've seen and through my talks are stuff that's created in the design and construction phase really isn't of value to the asset management people. So they tend to not really care about a BIM model. But if you had talked to them and put those attributes or that information into that workflow, they would value it. So all the stakeholders, and Phil will talk in detail on that on a project. A well thought out plan, I'm not going to spend a lot of time because Phil will, but in the building world, every project has what's called a BIM execution plan, and that plan details out everything about that project entailing technology, everything, from file structure to the type of software is used. And that's what's inherently needed for any BIM project. You have to have that information laid out front. And again, Phil will feature that and talk about that in depth as well. Some of the other ones up there, which again, I think probably at the bottom is, I would like to see us focus on a project and develop from it versus try to launch an entire program at an agency. I think if you go back into the 1980s when CAD was they didn't have all the answers for CAD. As a matter of fact, they didn't even have layer level structure back then, or for my painful use, no undo button was even around back in the day. And they learned as they went along. And I think the successes and lessons learned from these projects should be leveraged and done to the next one. And you eventually will build a robust program. But I also want to state that a BIM execution plan is a living, breathing document. It's going to constantly change. If you referenced the earlier slide, change is coming, and we're going to have to react to new change in the future. There'll be new things to deal with. It'll be holographic imagery we'll have to figure out. Or more importantly, maybe some issues will be, we're talking automated vehicles and connected worlds. How do we fit into all of that as well? So many challenges lie ahead. So I think what I'd like to do is wrap up real quick so Phil can actually show you stuff. Training, huge, important. These are all things that we've learned you can do. I think another significant concern for me is attrition at the agencies. There's a lot of people leaving these agencies with a lot of brain power. How do we move forward when we actually have less people to deal with there? Or how do we recruit new people to the agencies to breathe in life to these projects? So certainly something to be aware of out there. I'm going quickly because I want Phil to speak. So let's just, we still have a lot of analog workflows we're trying to apply digital processes to. We need to change how we think. We spend all this effort to create a 3D model, and then we end up creating PDFs to give out in the field. Again, you're still thinking with the old mindset. Stuff like that needs to change. And the adoption of the change is slow. I know we got a long way to go in implementing BIM or digital twins or digital delivery or whatever we're going to call it. So with that, I'm going to just pass it over real quick to Phil so he can actually talk about some of his experiences implementing BIM workflows on several NISDOT projects. So Phil, I will hand off to you.
Thanks, Chuck. Okay, we're going to jump ahead to the slide. There we go. Great. So originally I was going to talk about some of the ways that New York State DOT implemented the BIM program. But right now, I think I want to concentrate on actual case examples, project examples that New York State DOT is working on. So just a few background facts is New York State DOT has had 12 BIM projects, and to date, 6 have been completed, worth about $1.5 billion. And we currently have 6 in progress right now with a value of around $3 billion. And all of those are down in New York City. So that's the only region right now that's applying BIM and doing it very well. We've been working there in the BIM world since 2016. Actually started with our first project. So in that first project, here's an example of what's the value of BIM. So you have a 3D model instead of a set of plans. And in this case, there were utilities, and this is an old slide, but it's so important because we started right off from the bat reviewing a 3D model that was prepared by a consultant. And you'll notice there's a couple speed bumps on one of the ramps. Well, those are 2 36-inch water lines, water mains, that were in the wrong spot. So while this was out for award, we were able to identify that design error and make changes that saved $1.3 to $1.5 million right from the start. This was before we even let the project. Our first one was a design bid build. So we were fortunate because we were able to estimate what the cost of the BIM work would be to the contract. And then we were able to assess it afterwards to see what the value was. So our process is we have a planning, it starts in planning, we start to generate this digital information. And it's a database. It really is an enterprise database for the agency. And then in design, so I've heard people say, well, BIM costs more. BIM costs a lot more. Well, not if you're designing in 3 dimensions in 3D CAD anyways, which New York State DOT's been doing since 1995 approximately. So we're able to take those 3-dimensional models and use them for construction purposes, and that was a big change, 8, 10 years ago, when contractors started wanting those 3D models. They were pulling that data. We weren't pushing it to construction anymore. And that was a huge change. So now the value is leveraged by construction. They don't have to rebuild that model. They can just take the design model and utilize it for their advantages. So what we have in New York is a BIM specification, right, for all of these projects. And in that specification, it includes a BIM model management plan. We don't call it an execution plan because in order to execute something, you have to have a management plan. And that's what this is. It describes the relationship of all the data. It's an integrated information model. And so that data is used for many, many things, including design analysis, constructability analysis, schedule. We've got 11 performance indicators that we measure on a regular basis for all of our projects. And this is kind of just demonstrating how we use the data and the level of development you'll see there in one of the images. So construction gets it, takes that model, and then enhances it to what their needs are. The contractor can take that model, slice and dice it, work on their constructability, work on their sequencing, work on their schedules. When we have a proposal with our BIM spec, they provide a model of an animation of how they're going to build this project, all proposers. So they're creating this model already. We're able to use that model in evaluating who the proposers are and how well their proposals meet the needs of the contract. So in construction, this is one of the BIM model is the actual contract document. We've had 2 contracts that way so far. And you'll see that depending on the contractor, they can arrange that information, utilize it to whatever they want to help them build the job, but it also helps us manage the job. And then these are some of the models that come out of that. Then it goes to operations and asset management. And you'll see, here's Kew Gardens 3, as a matter of fact, our first BIM project. And then was Kew Gardens 4, a multi-phase contract. And this is the data that we have for operations. This is the as-built model that we then use for operations for their needs. So again, we're leveraging the data. It's an integrated information model. And the deliverable is the 3D model plus a GIS data set with all of the metadata associated to the assets. We've based on our GIS requirements. So again, we've got several areas in the agency contributing to how this specification provides information that they need to do their work. That's the value in it. Okay, so one of the huge advantages of this model in construction is constructability analysis. So we run into unexpected field conditions all the time, and this was a case of, well, we don't know how we're going to lift this strut. We think we can get a crane in there. Can we really do it or not? So we modeled it. The contractor modeled it, did all their analysis. We determined it was going to work. They did it. It saved 6 weeks, at least. Just an example. So when we do 4D, 5D animations for our projects, we review them on a monthly basis. They're submitted with a CPM schedule update. Every month there's an update. So we can review what the 4D, 5D animation is showing us compared to the previous update to see how is that going to affect schedule, and we also model cost. So we have a 5D model included, and this is examples of the actual conditions on the site. This is Kew Gardens 4, and the actual modeling corresponding to that same time frame. So we analyze, are they on schedule? They can't just say they are. It has to be illustrated in their modeling. Again, in the field, certain conditions come up. So we had an area that we felt wasn't modeled correctly. We're on the site all the time. We're looking at the plans and the modeling, and it came apparent to us that it's really going to be addressed in phase 3. This is phase 2. So it helps us look at the information available to see are the decisions in the field being made correctly, and it gives us the opportunity to call those things out to analyze them. This is an example of a screen capture of a 4D, 5D animation. We're looking at, again, comparing the CPM update baseline or the previous approved baseline schedule to actual. And this shows that, yeah, we're actually ahead of schedule. You can see by the highlighted area. And this is, again, it's a screen capture. I wish I had the animation showing, but it shows on the bottom, you'll see the actual cost, our earned value curve that we require as well, and then how the progress is going in terms of schedule. This is another very, very large project, the Van Wyck Expressway, from Kew Gardens interchange to JFK Airport. It's about a 3.5 mile project length. You're seeing phase 3 on the screen, and on phase 2 is the railroad bridges. There's Long Island Railroad crosses over the Van Wyck. It's triple-decker railroad bridges, incredibly complex, 16 tracks. So this contract is going on concurrently, right? And then you have phase 1, contract 1, 9 different bridges that cross the Van Wyck. All these projects are going on concurrently. We were able to do this because of BIM, because we're able to manage the data, the modeling, the sequencing of the work, how contractors work together. This gives us the ability to be able to manage it in the best possible way. And then, again, some examples of the deliverable, the as-built model. So the information provided from all the modeling goes to asset management. And they have now an updated record of the entire project contract area, all the assets, the metadata involved. I think there's 40 different metadata requirements involved, giving our asset folks exactly what information they need. And how do we know that is because we asked them. We said, we're developing these models. What data do you need as a customer so that we can provide that data to you in the formats that you need it, so that it helps build the information, helps build value. We're leveraging the data further. And we're also measuring performance, right? So as we look at our first contract, we had 11 different performance indicators built in there. We measure that on a regular basis. These are the performance indicators. You can see them. I won't have to read them. But including innovation, we look at the business process. We assess those things, how it's improved the business process, quality, how we use the data utility, and data integration. All these things are extremely important, and it helps us report on success. So we have a dashboard that we have for every project. We keep this updated on a monthly basis. as well as scorecards on a monthly basis. And we have this conversation with the DB, design build team, on a monthly basis, saying, here's where we're at. You know, are there some issues coming up? We can look ahead. We can look back and say, well, here's some things we need earlier, more timely, please provide. So it really does help us manage contracts. And so far, within the number of contracts that I had mentioned, all of those projects have been on time, and if not earlier, and on budget. So we need more contracts to continue to assess. It's a small population of projects, but we will continue to manage and monitor the performance of it. And so far, the results, the benefit has been significant. So we're building on qualitative data, and that really helps us assess the performance. And so with that, we can measure and make adjustments to our specification if necessary, which we do. We tweak it quite often, depending on the contract coming up. And the last thing I just want to say is for our takeaways. It's here. New York State DOT is using it. It's been extremely beneficial to the New York City region. But it does require champions. The director in the region is a big champion of BIM and has been since the start of our implementation. And it really does require that special kind of champion to help make sure we're going to sustain this program. And I just wanted to say how the benefits have been significant, 10 to 20% benefit over cost. And we measure it on a regular basis, as I said. And that's pretty much it.
Wow, perfect. Questions? Lunch? No, questions? Sorry, we're on mine. I have a question for Phil. So, Phil, you know, some will say that New York is a big program, these are huge projects. You think it's scalable?
Yes, absolutely. We actually, before I retired and left the department, we had a plan to use BIM for every moderate to complex projects that's defined by our project development manual. Moderate project is a $20 million bridge, let's say. 17,500 bridges in New York State. To complex projects. New York City, every project's complex, so it's a given. But the ability to manage contracts simultaneously. So Kew Gardens 4 started 3 months early because we were able to direct the contractors on where to work. And based on the modeling, we could show the schedule, no impacts to any of the schedules. Right. We do the schedule and cost are built right into the 3D, 4D, 5D modeling, so we can analyze it. So, yeah. Yes.
And I'm sure you'll be evaluating what I'll call the post-construction. I mean, a lot of that has been the construction benefit or the project development delivery, but then you mentioned the as-builting and how that's going to go in. I know Craig from New York likes to say you can't turn a teaspoon of dirt without touching something.
Utilities,
you know,
yeah.
utility or something in New York. Any other questions?
Yeah. And speaking of utilities,
Yeah.
we map all the utilities. Let's say they have an open excavation. If we identify, which as David just mentioned, as soon as you put the shovel in the ground, there's utilities that we didn't know were there. The contractor has to map those. So we're collecting more assets as we go that we weren't aware of. So that's just another advantage.
I got one for Chuck, since I don't want to, have you just not get out of here without a question. So Chuck, you mentioned the workforce challenges. I don't know, speak to that quickly. I feel like it's a catch-22. If we don't move to this technology, we will not attract the workforce of the future. I mean, this is what they're used to, this technology. So, I don't know, can you just give your thoughts on how we can, address that workforce situation?
I mean, actually, I think embracing this workflow would be enticing to some. Oh, we just got the hook on this. Oh, you want me up there? Sorry. That's what he's saying. Yeah, I agree that, this type of technological workflow would be enticing to the younger generation who is eager and more adept to change. I think there's bigger challenges that the agencies need to deal with as far as attracting talent and then retaining talent. We experience issues where we'll work with an agency and then the senior level people leave, and there's a huge vacuum behind that. It's almost like starting an initiative over again. I think, as we mentioned earlier, general acceptance and adoption will help lead to retaining staff and actually nurturing new staff. I'm quite encouraged by Iowa and Texas that have both released RFPs for digital delivery at their agencies, and I hope that trend will continue. Very encouraged by that.
Awesome. Yeah, it is a journey, and so I think that will do us so that you guys can, oh, sorry, Cameron, go ahead.
It's going to ruin lunch.
No, don't.
There's not that much lunch. You don't get lunch anyway, Chuck. You got to work. I saw some things on there that I hadn't heard in a while, Chuck. I saw, what was it? Work planning?
Work packaging, work planning?
Yeah, work packaging. And we talk about automated vehicles, AR, VR, AR, automated vehicles, connected vehicles. And since when I was in school, we talked about work packaging, we talked about automated construction. Now it's automated vehicles. So where does BIM, automated construction, is automated construction and work packaging still a thing? Because, I think that could really bring our construction costs
There's
down.
work packaging and then advanced work packaging, and that's where you actually are developing a specific construction package, and using a program like Synchro allows you to educate those packages into the overall construction plan. So that's a industry that's really starting to explode out there, the advanced work packaging group. There's, I think it's awp.org if you want to learn more about that. Automated vehicles, every cell company in the world is looking to capitalize on that, and talked to some folks at AT&T, and they need 5 millisecond latency or less, so they're trying to build infrastructure to do that, and a lot of that will be along highways and roads. So having that accurate digital model, as Phil's explaining earlier, only enhances that process. So I see a lot of, again, more use of data for something else. You're taking roadway to help analyze cell tower placement, a simple example, but that's where we're headed.
I'm just going to say to close that if you get the right data and you organize that data, I don't really see it's unlimited what we can do with it. So to me, that's the foundation of it, is getting the data, make it a little more exchangeable, and organizing it for the benefit of the enterprise, so that it's not these one-off handoffs of things. So I just want to give our presenters, all of our presenters, one more round of applause. Thank you for being here, and please go enjoy your lunch.
I got 10 more questions. All of them for Chuck. Could you stay, Chuck? Just I got, a couple hours. We'll be good.